Here are some elevator problems. So in each case, just wait till the video pauses and asks you and choose the best answer for each one. Alice is in an elevator and feels twice as heavy as usual. Which of the following must be true? The elevator is ascending or moving up. The elevator is at rest. The elevator is descending or moving down. Or D, there is insufficient information to talk about her velocity. So take a second, think about it. Here, there's insufficient information. What we do know is that the elevator is accelerating upward because the apparent weight is more than her gravitational weight. But we don't know if this is the case of a thing which is moving upward and getting faster, or a thing which is moving downward but then getting slower. In both cases, those would be an acceleration upward. So in both cases, we would have a greater apparent weight. Bob starts from rest at the top of a building and takes an elevator towards the ground floor. Which of these is true in the early part of his trip? All right, here we have that he starts at rest and then heads downward. So at least at the start, his velocity is at rest and then getting more downward, at least in the early part. And this is a thing which is accelerating downward. Since the acceleration is downward, the true weight is more than the apparent weight. The apparent weight is less if you accelerate downward. So we end up that he feels less heavy than his true weight. Charlene takes a high-speed elevator to the observation deck of the Empire State Building. The elevator accelerates upward for 2 seconds, and then, after 10 more seconds, decelerates so that she reaches the deck nearly at rest. What can be said of her apparent weight at 6 seconds? In this case, it's equal to her true weight. How come? Because if we have acceleration at 2 and then stops, and then we go 10 more seconds before she decelerates, she must have an acceleration of 0 in between. She must be rising at constant speed between 2 seconds and 12 seconds, which means the acceleration is 0, so her apparent weight is equal to her true weight. Dexter masses 75 kilograms. He rides an elevator which is heading upward and getting faster at the rate of 2 meters per second each second. What is his apparent weight? Well, here we're saying that it is accelerating upward, right? It is going upward and getting faster. So the acceleration is upward, which means that the apparent weight is more than his expected weight. In fact, we know the apparent weight is his mass times g plus the acceleration. So here it's 75 kilograms, 9.8 meters per second square plus 2 meters per second square, which is more than 735. So he must have this one. I don't even have to get the number. His apparent weight is 735, and this must be more than that. Eugenia decides to conduct a free fall experiment in an elevator. She drops a ball from her height of 1 meter and sees that it takes 0.3 seconds to hit the floor, which is true. So let's find out the acceleration. So we have that the object starts at some height, which is 1 meter, and then falls to 0 meters, starting at 0 seconds and falling to 0.3 seconds. So we can say y equals y initial plus v initial t plus 1/2 a t square, or 0 equals 1 meter plus vi t plus 1/2 times the acceleration times 0.3 square. So the acceleration is twice 1 meter over 0.3 seconds quantity squared, which is 22 and some. All right. Since the acceleration is much greater than the free fall value, the elevator must be accelerating upward. The floor must be coming up much faster to hit it than we expect if we were just to drop it. Fergus stands on a scale in an elevator initially at rest. The graph of the scale's reading is shown. At what time is the elevator accelerating upward? Well, since he starts at rest, this is his true weight, and during this time his apparent weight is more than his true weight, so the elevator must be accelerating at that time. That seems to be between 0 and 6, so it must be here. Same problem, and we ask, at what time is the elevator undergoing the acceleration of greatest magnitude? Here we can see that during this time, he's accelerating downward, but by a lot more. His difference from his true weight is a lot more, so this acceleration must be much more than that acceleration. And of course, there's 0 acceleration during this time, so it must be at 7 seconds that we're getting the most. All right, so far we've had Alice, Bob, Charlene, Dexter, Eugenia, and Fergus, and this is just if you've been paying attention in class. Who would be next according to the list of characters that we use in class? Think of this as a bonus point because it won't count against you, but it would be Gertrude. Gertrude is our G character. And that's all the problems for now.